Okay, pre-calculus, chapter 1-4 vocabulary. Now, this section 100% is a lot of review, major review from Algebra 2. I mean, we talked about it in school. Because I took the personal day. Okay.
You took personal knowledge, what did you do?
Now, shifting, reflecting, stretching graphs. Let f of x equal your original equation that the following is true. I'm going to let you guys copy this down. Can I do it here? Is everybody okay with that? Okay. First, let's read that one. Okay, now, if let f of x equal your original equation, the following is true. F of x is your original equation, and that means we're going to create a new equation. That new equation is going to be titled h of x, because f of x is already defined to be something. So now I want h of x. So h of x is f of x plus c, meaning I've moved it up the graph to c units. Doesn't matter what f of x is. What matters is I took that f of x and I pushed it up c units. If I have f of x minus c, that means I pushed it down c units. If I have f of x minus c or plus c inside the parentheses, that's going to be a horizontal shift. Plus c goes the opposite direction of what we would think. We would think that would go to the right, but since it's inside the parentheses, it goes to the left. Okay? If I have f of x minus c inside parentheses, again, we would think that would go to the left, but it actually goes to the right. Do we all understand those shifts? Okay? This is not difficult stuff today. This is very easy stuff today. This is stuff that you got back in Algebra 2 with the transformations. Okay? So what I'm talking about today, I give you this standard equation of a parabola, y is equal to a times x minus h quantity squared plus k. Remember this? The HK stands for the vertex. HK stands for the vertex. And we have what we have called is a parabola, our U. Okay? So y is equal to a times x minus h quantity squared plus k. That's going to be your standard form for a parabola. And that is extremely important because it allows us to have the vertex fall directly out of it. What's a vertex? It is the maximum or the minimum value of a parabola, meaning it is the point where the graph changes direction, right? You all understand that? It's the point on the parabola where it changes directions. If it's a maximum, it's going to change from increasing down to decreasing. If it's going to be a reflected parabola with a minimum, okay, or I should say with a minimum in this one, okay, it's going to be decreasing, it's going to change direction, it's going to start to increase again. We all understand what I just said, yay or nay? Now, the A value. The A value is what shrinks and stretches a graph. It also reflects it. The A value is what stretches and shrinks and reflects a graph. If the A value is greater than 1, then what we have is, we call that a stretch. Now, everybody, drop your pencils a minute. I want you to physically stretch. What are you doing when you stretch? Everybody look over. What's he doing right now? His hands went up above his head. They went up to his neck. So if you see me, my hands being this nice little bowl, okay? Do you see that parabola? And if I say I'm being stretched, that means my hands go up higher. The bowl is still there, okay, but it's gone up. Do we understand that? Okay, do we all understand that, yes or no? Now, a shrink is going to be whenever your A value is between 0 and 1, meaning it is a fraction. You're going to have a shrink whenever it's a fraction. Think of it this way. If someone is 7 foot, they're extremely tall, right? Right? Half of 7 foot would be what? 3.5 foot. They shrunk, isn't it? Okay? So half of that, think fraction, is going to be a big old cereal bowl. Instead of a coffee cup like we normally have, we got a big old fat cereal bowl, right? You understand that? So a shrink is going to be whenever we have A value to be a fraction. Now, we have a reflect when your A value is going to be less than 0. What does that mean, it's less than 0? It means negative. Do you understand that? If your a value is negative, then that means it's going to be flipped over the x-axis. Do we understand what I just said, yay or nay? Okay. Now, parent functions. Who in here has ever heard about parent functions? All of my elementary students have heard of the parent function. How many of you juniors have not heard of a parent function? Oh, I'm really saddened by that. A parent function is basically a function that all of the other ones are going to look like this function, okay? What's going to change is it might be picked up and moved to the right, to the left, up or down. Right, left, up or down, okay? So that's what you have to look at in that standpoint. So if I have a parent function, f of x is equal to c is going to be my first parent function. What does f of x equals c look like? C is a constant. It is a number. A constant is c. So therefore I have y equals a number. What does y equals a number look like? A horizontal line. It's a horizontal line. So anytime you have a number, they're all going to be horizontal numbers. Do we understand horizontal lines? Yay, nay? That's one parent function. Another parent function is going to be y equals x. Let's try it this way. It's horrible, isn't it? And this is why we have technology to cheat. Because I can't draw a line with the origin and say, my soul right there, could I? Okay? Okay? Now what we have is just a line of positive slope, meaning it's x, it goes to the origin. Has anybody ever heard of direct variation? We talked about direct variation last year. Direct variation is the equation that goes through the origin every time, and its slope is the actual constant of variation, okay? And we used to be called k. Remember, you guys were all like, why did it change it to k when slope is m? Remember, we talked about that last year. So this is the concept right here. Direct variation would be another parent function of x. Now what about this one? F of x equals the absolute value of x. What does that look like? Birds fly in a form of a V. This is going to be your lovely little V. Okay? So the absolute value function is a parent function of its own. Okay? Then what about this one right here? The square root of x. I call this the one-armed bandit. What does the one-armed bandit look like? What? It is a half parabola on its side. It's a one-armed bandit. I just liked it. I call it the one-armed bandit. Makes me happy. Bandits make people happy, don't you know? And what does x squared look like? It's a parabola. We already talked about this one. And the last one is going to be x cubed. We should be writing these down. Looks like what? I call this my spaghetti function. I call my spaghetti function because you could cook your spaghetti and throw it against your wall and it kind of looks like a cooked noodle, right? It does. But doesn't it kind of look like a cooked noodle? I mean, come on. It's your kind of spaghetti. Yeah, that probably doesn't work. Okay, now I want to talk about when these functions are odd and even. So to be an even function, what does that mean if you're even graphically? You reflect it over the y-axis. So therefore, if I reflect my x squared over the y-axis, does it lay directly on top of each other? Yes, so this is going to be an even function. How about x cubed? What type of a function is that? Wrong. It's odd. Why is it odd? Because to be an odd function, you flip it over the x-axis and the y-axis, and they'll lay directly on top of each other. That's what an odd function is. Do we understand that? I can literally fold that over the y and fold that over the x, and they'll lay directly on top of each other if I drew it nicely. We all know that. I struggle in that area. Artistically challenged I am. Now, how about the square? How about the absolute value of x? What type of function is that? It's an even function. We can clearly see that I can fold that over top. What about the square root of x? Neither, because it's the one-armed bandit. Do we understand that? Good job. What about f of x equals x? I can fold that over twice, can't I? Can anybody tell me what you've noticed? That ones that have degree of 1 are what type? Odd, and ones that have degree of 2 are even. Not always true. Not always true, but it's a very good thing that you can have an estimation of where it could be. Okay? These are the parent functions. Now what I want you to do is based upon those parent functions. That is f of x equals x squared. Now I want you to tell me what happens to h here. Up, down, left, right, reflect, stretch, shrink. It is not a stretch of 3. We went up 3 units. Let's see if that's a true statement. Let's go to B first before I do that. B, what do you think's happening with B? I'm sorry? It's going to go down 3 units. Now let's look to see if that's a true statement. Look at the graph of x squared plus 3. It absolutely went up 3 units. Look at the graph of x squared minus 3. It definitely went down 3 units. Do we all see that, yes or no? We're good? Okay, moving right along. How about this one? What's happening to this one? It's plus 3, so your instinct is saying that it goes to the right, but it's not going to the right. It needs to go to the left 3 units. And how about this one right here? It's going to the right 3 units. And again, you can look at the graph to determine all of that too. Do we all see that, yes or no? Now, did you see how lazy I was when I put U3, D3, L3, R3? Am I allowed to let you, are you guys committed to do that? If I'm doing it, you're doing it. Or not, right? It's totally legal. You can be lazy just the same as me. Now, I give you the parent function, f of x equals x cubed. Now, I want you to tell me, reading these things from left to right, what's happening to them. So letter A, what's happening to this function?
Down 1.
It's down 1 unit because it's minus 1. How about B? It's to the right 1 because it's inside of the parentheses. Do we see that? And it's minus, therefore it's opposite of what we think. Read this from left to right because that's how we do mathematics. Now from left to right, what does the 1 do to the graph? It's going to go to the right 1. And what does the 5 do?
5.
Up 5 units. Go from left to right. What does D? Letter D. What? Up 6. Do we understand that, yay or nay? We good? So far, there's nothing new, right? You guys remember this? Okay, now let's quickly, you don't have to write this down because you already did the A values earlier. I just want to make it very clear to you. If f of x is the blue graph, then f at negative x is going to be the red graph. You see it's reflected down over the x-axis. That means when it's reflected over the x-axis, f of x is equal to negative f of x. Over the y-axis, f of x is equal to f at negative x, meaning even and odd. Okay? Now, from left to right. Not worried about that part. We already talked about it. We good? From left to right, what's happening to this thing? What's the negative do?
Reflects positive.
It reflects it where? Over the x. What's the 4 do? To the right 4. What's the 5 do? Up 5. Do we all understand that, yay or nay? You good? It's more verbal. This is how you're. Are we good? Okay. Now, again, we already talked about this. You do not have to write it down. This is stuff that we talked about with A value. If A is greater than 1, it is a. If A is greater than 1, it is a stretch. If A is a fraction, it is a shrink. If A is negative, it is a reflex. Do we understand that? So we have 1 fraction and less than 0. Keep those in mind. Now what's going on to this thing? Go from left to right, please. What's the first thing you see?
Negative.
What's the negative do? Reflects it over the x. What's the 1/3 do to it? It's a shrink by a factor of what? By 1/3. What's the 2 do? It's going to the right 2, and what does the 5 do? Do we all understand this?
If it was a positive 1/3, it would stretch by 1/3.
If it was a positive 1/3, it would still shrink it by 1/3. The reflect, we would not reflect because it would be negative. Negative is the reflection. Positive means it's the normal. One at a time, Alec. The stretch would be something like this. So if I have y is equal to 3 times x minus 4 cubed minus 7. What's that 3 doing? It's stretching it. So I have a stretch by a factor of 3. What's the 4 doing? It's going to the right 4. What's the 7 doing? Down 7. Are you good, Alex?
How'd you know it's reflecting over the y?
We're going to talk about that in a minute. Morning.
How did you say reflect over x on the one? How did you know?
How did I know? Because it's x squared. This is x cubed. Okay? And I'm going to talk about the next function here in a minute, and that's going to answer Colton's question. Okay, look at what we got going on here. I have f of x is equal to negative square root of x plus 5. Now, things start to get shady here. Okay? You guys start to look at this, and you're like, what is going on? I don't understand this. So if you're not understanding this, when in doubt, what do? Graph it. Did you see that? See that? When in doubt, graph it. Yeah, you're going to see me do that all the time. The stupider I look, the more you remember something. So I'm okay with that, as long as it's embedded in your brain. So when in doubt, graph it. Right? Aren't you annoyed by that already?
Yes.
Amazing. That's awesome. Graph it. We ready?
Yoder.
So get out your calculators. What do I want you guys to do?
Graph it.
That was great. Loved it, man. Hee
No, I know.
I do.
I'm talking to Cole.
Okay. So you want to graph.
Negative square root.
Now before, no. Just don't be getting so darn excited yet here, folks.
One-armed bandit.
It is the one-armed bandit. You are exactly right. We all should know that that's the one-armed bandit, already. Huh?
It is definitely.
So thank you.
No, I wanted to just graph the square root of x, because the square root of x is going to be our one-armed bandit. Okay? That is the one-armed bandit right there.
Do it.
Fine, that's the parent function. Okay, why did I graph that? Because over here, is the square root function, correct? So that's the parent function. Do we all understand that? So tonight's homework, you're going to be asked for 2 things. To 1, tell me the parent function, and to 2, tell me the transformation. Does that make sense? The parent function is what you're comparing it to. You up, down, left, right, reflect. Yep. So the parent function to this is going to be what? Is f of x is equal to the square root of x. That's my parent function. So if that's my parent function, I want to compare this thing to my parent function. So there's my parent function. Okay? I cannot. Shh.
You have any function like that massive value.
That's the value. So if I have a graph that has anything like an x squared in it, what's the parent function? X squared. If I have a graph that has x cubed in it, what's the parent function? X cubed. If I have 3x plus 2, what's the parent function?
How do you
X.
know?
We're getting there.
Wait,
We're getting
the
there.
next thing is.
You all need to be patient with me. Okay, now stop and listen. So now I'm going to graph the square root of negative x. Square root of negative x. What happened whenever I had the square root of negative x? Do you see when the negative was inside of the root, it reflects it over which axis? The y-axis. That's what everybody's going to do. When does it reflect over the y? When does it reflect over the y? Okay, that's when it reflects over the y. Do we all understand that? When the negative is on the inside of the square root. Now, hit tab, and I want you to do negative square root times x. What happened to that one? It reflected it over the x. So when in doubt, what do we do? Right? Come on, I can't. I just can't. All right? Now, do we understand this, yes or no? So if I want to compare this to that, I'm going to hit tab again, and what was my function? Negative square root of x plus 5. Before I hit enter, what do you think is going to happen before you cheaters say anything? I'm talking to the people about graph yet. The negative on the outside is going to reflect it over what? The x, not the y, because the y is on the inside, correct? And then what is the plus 5 going to do? It's going to move it to the left. So let's think. Is that what happened to it? It sure did. So when in doubt, right? Come on, you all love it. Tell the truth. Okay? Are we good on
Sorry,
this?
don't laugh.
Yeah.
Do we get when it's reflected over the x and it's reflected over the y? Okay. So if I come back over here to my lovely little graph, I'm going to say reflected over the x and then to the left 5. We good? Now what do you think is going to happen to this one?
Flip both X. That way.
It's going to flip or reflect over the x and y, and then it's going to go where? To the left 5. So let's come back over here and check that out. I'm going to just get a new document there, a new problem, just because it's hard to see here. So that's going to be negative square root of negative parenthesis x plus 5. Do we see it? You good? So we flipped it over the y, and then we flipped it down. We all see that? We're good to go?
Go back.
Wait.
Where am I going back?
The X actually.
To my, this? Okay. Any questions over what we just talked about?
I think it's parentheses on.
Yes. Okay, from left to, this is number 12, let me pass out tonight's homework. Tonight's homework is a worksheet. I know you guys like the worksheet, it's much better than the
You
worksheet.
probably have that correctly crafted.
You shouldn't. Everything that I just talked to you about, you shouldn't. Okay, but let's talk about the graphing calculator concept here in a little bit.
Wait, are we still on a process where we do the homework in class and do the notes for homework?
I'm doing 50%, 50%. I haven't decided yet. It depends on where my lesson plans fall and how I want them to do. I can't count.
So, well, that, flip, stretch it down.
Okay. Now, for problems 1 through 6, it says compare the graph of function with the graph of f. All you have to do for problems 1 through 6 is up, down, left, right. Now, I want to draw your attention to problem number 6. Erase the square root of x, not 16 minus x squared. That's not supposed to be squared. Number 6, get rid of the squared on the inside of that. It's just supposed to be the square root of 16 minus x. There's not supposed to be any squared on number 6. Okay, it was an error on my part. Sorry. I don't want to waste the copy though. Now, 7 through 10, again, it says compare the graph of function with the graph of f of x equals the absolute value. So are there any questions up, down, left, right, stretch, reflect? We good? Okay, now, 11 through 22. This is where you guys get confused. So, it says directions for problems 11 through 22. A, identify the parent function f that is related to g. I give you g, and I want you to come up with the parent function f. So number 12, what's the parent function f? Well, g has what in it? A square. So what's the parent function that goes along with that? X squared. That's letter A. Letter B now says to describe the transformation from f to g. So what did I do to f to get to g? What happened to it? Read g from left to right. What does that 2 do to it? Third period really struggled with that. It does not stretch it. Because, look at it, rewrite it if you have to. Negative x plus 5 squared plus 2. That's exactly the same thing. When you stretch or shrink, something's attached to the parentheses by multiplication. Is there anything attached to the parentheses by multiplication except for a negative sign? Do we understand that? I guarantee I am so throwing one on the quiz on that like that. I guarantee it, because I've got both periods on it. Okay? So what's happening with that, 2? What does it? What happens with it? It does it, man. It goes up 2 units. What happens with the negative? It reflects it over the x, because it's a parabola. Now what about the 5? It's going to go to the left 5 units. Do we all see that, yay or nay? So that's what you need to get done on tonight's homework. Now look at number 14. What is its parent function? F of x equals the absolute value of x. So f of x is equal to the absolute value of x. There's my parent function. Now part B, what was the transformation? Read it from left to right. What's the negative do? It reflects it over x. Then what? What's the 2 do? Stretches because it's not a what? It's not a fraction. So we have a stretch of 2. What's the 1 do on the inside? It's going to go to the right 1 unit. Do we all understand how to do 11 through 22? We good? You can't say kind of on something like this. You say kind of because you want me to do the whole homework for you. And then that means you're going to get out the video, you're going to start listening to the video again. Okay, now 23. For 23, it says given f of x and g of x, determine each of the following. So letter A, B, C, D, E, and F. They're all exactly the same functions. I'm going to do A, C, and E for you. So A says to do f plus g. What is f? What's g? Do I need the parentheses? No. Why would I put parentheses there, though? If you're subtracting, you have to do what with the subtraction sign? Distribute it. So I don't need them, so I drop this. And there's f plus g. Now, what is f times g? Well, f is going to be the square root of x plus 6. G is going to be x squared minus 5. And I can distribute this if I wanted to. It's really not going to make a difference. I would accept either answer because they're both exactly the same. Do we see that? Can I do anything else with that? No, it's done. Yeah, it's ugly, but it's done. It is ugly, but it is done. Okay? Now I need to find the domain of f times g. The domain of f times g is that right there. There's f times g. Now what's the domain? Well, I'm talking about restrictions. When do you have a restriction? When you have a square root. Do I have an even root? Yes. So the junk underneath the root has to be greater than or equal to 0, so x has to be greater than or equal to -6. So x is down to the reals. It's greater than or equal to -6. I'm done. I've done problems from every section of tonight's homework. You should be absolutely fine. Tomorrow, you will have a 1-5 worksheet. Thursday, you're going to have a quiz over 1-4 and answer questions over 1-5. Friday, I will not be here. There will be a review over sections 1, 4, and 1, 5. Any questions over what I just talked about?
Yes, sir.
Exactly.
That's
Negative.